Hello, welcome back to PyraPOD. I'd like to do a comparative study, basically an experiment to compare the passive solar and the PyraPOD solar. Okay, we call it PyraPOD solar because it's based on the solar roof bubble tech that Richard Nelson invented. Um, I like to compare because now we know the passive solar has been accepted by many people. Some places, some cities actually, some even province, some country even want to adopt passive solar as the standard for future buildings. Um, yeah, for that reason, I like to do an experiment to compare the passive solar that has been accepted and versus PyraPOD solar. Okay, so to prove that PyraPOD solar is much better and much cheaper in cost and but the performance is much better. Okay, so basically, as you can see, we have two bubble, two tower, right? Light tower, right? Lighthouse. We just build it in the shape of a lighthouse, right? Um, the two exactly same. The left will represent the solar, passive solar, and the right hand side will represent the PyraPOD solar. Um, so basically, they are exactly the same, but the only difference is that I'm going to use for the right hand side tower, I'm going to have a bubble machine, a bubble generator inside the chimney at the bottom, and then there's a pump pumping soap liquid, right? You need soap liquid to produce bubbles. So everything the same. I'm going to make sure the liquid in the right hand side is at the same level as the left. So the left will be just pure water. Uh, the right will be soap liquid. Okay, and yeah, and all the rest the same. And then I'm gonna do measure the four temperatures, right, on both sides. I'm gonna measure the outside temperature, right, and I'm gonna measure the inside temperature. The inside temperature, I'm thinking is we're gonna choose this chimney, right, basically a place temperature sensor in the middle, right? So that what you measure is the air temperature, right? Not the sun exposure, right? So this way it's more accurate. And over here the same. Over here the same because we know the there will be some bubbles inside the chimney, but because the yeah, but because the wall effect, so when the sun heat onto the wall, and the chimney will actually heat up, faster than other area maybe. So anyway, that's a perfect place to place a sensor there. So the same position, and then we're gonna measure both liquid, right? The water, and then the soap liquid, soap solution, and also the air temperature outside the wall. Okay, we'll probably place at the same place. I will say somewhere on the northeast corner, right? That's probably a good location. Somewhere in the middle, right here, and somewhere here, exactly same spot, so that we can do some comparison, right? So with the four temperatures, I'm sure we can do a lot of analysis and to even to estimate the R value of soap bubbles, right? because in this case this is air insulation basically, and here this is bubble insulation. We're going to compare. We're going to know that the left hand side will be very close to a passive solar building, but the right hand side is actually is proactive solar. Okay, because we're going to use the bubbles, right, to collect the solar thermal energy, and then the fan break it, and also the bubbles burst into liquid, and then that liquid will bring the solar thermal energy back to this soap reservoir, right? Okay, so and we have insulation on both sides the same. I like to build a wall around it, and the 2-layer separation for the wall, just like the normal building, it will be 6-inch in thickness, right? I plan to place 1x6 board in the middle to hold it, and then I'm going to use the normal insulation that every builder is using, right? So to insulate all the walls, and so to imitate the normal building, right? The bottom, as I explained, I'm going to have 2 layers of R10 board. I purchased from Home Depot. Okay, so this way we have R20 insulation roughly, everywhere, and then for the new wall, and then the up portion is just imitate a single layer greenhouse, right? But in this case, because the bubbles will fill the space between the chimney and the external film, right? So it form a bubble wall, right? Bubble wall, and the bubble will protect the space inside the chimney, right? So this way we can measure the temperature in the middle of the chimney, and that give us the average for the inside temperature, and then and then we'll see after sunset how fast we'll measure the temperature drop, right? Because after sunset there's no solar gain coming in, right? There's only solar loss, and in this case it's air insulated. In the right hand side, that's bubble insulated. Okay, so by measuring the how fast the temperature drops, between the two, and then we can get a very good estimate as the effectiveness of the bubble insulation. Yeah. So anyway, so that's what I plan to do. Just make this video to explain it. If you plan to do it, if can, if several people, we can do it independently, and then the result will be better. Okay, and then we can maybe write a paper, research paper, to report this study. I'm sure this is a unique experiment, a unique study that worth doing. So that's what I plan to do. Okay, yeah. So if anyone want to do likewise, let me know, and then we can do independence work, and then we can maybe even write a paper, or individually, or just collectively. Yeah, whatever. Whatever works for for the situation. Okay, so that's it. That's basically that's what it is. I think that's it. Yeah. Yeah. So we know when the air is heated up, right? There will be circulation, right? I don't know whether there'll be some chimney effect, but the thing is that there's no. This is the closed area, right? There's no air coming in and no air coming out. So if there's some chimney effect, right? For example, the air rise to the top and then cold air coming down. If there's any circulation, I'm sure it's maybe some, but not much. But in our case, we force the we generate another kind of circulation because the bubble will be produced, shooting to the bottom, cover the entire surface, the soap liquid surface, right? And then expand, along the side around the chimney, and then rising to the top and then coming down, right? So the bubbles will be broken here because the fan will be here. So that's what it is, yeah. And yeah, but anyway, we just like to we are curious, right? We are curious what the result will be, and I'm sure this is a very good study, comparative study, and we're looking forward to the result. I have already ordered the temperature sensor. Will work out the system to automatically register, right, the temperature, and then we'll hook up to a computer. Yeah, maybe I'm thinking to set up a home assistant, operating system with a dedicated computer working for that, and that's new for me. But I studied. It's not that difficult. So basically, we like to monitor all the four temperatures, between the two, and then do some data analysis. Yeah, that'll be fun. Yeah. Okay, good. We'll let you know. We'll produce more bubbles. We'll produce more videos as I build the two and do comparative study. Okay, thank you.